this session of UMTS, we will be studying about the WCDMA concept. We will be covering the basic functioning of WCDMA, the radio path basics, and the WCDMA parameters. Now, as we know that WCDMA, which is a wideband code division multiple access, is the radio access technology which is implemented in our 3G UMTS networks. We know that this radio air interface is implemented between the user equipment and the serving node B. So there are different protocols which are exchanged between the different radio equipments. Like this is our access stratum, because the user is accessing the network with the help of radio access technology. So these are the different protocols which are being exchanged between the user equipment and the node B. So this is also referred as the access stratum. Now, if the protocols are exchanged between the user equipment and the main serving network, that is referred as non-access stratum. But we are here to discuss about implementation of WCDMA between the user equipment and the node B. So that means this air interface is responsible for deploying the physical layer of the architecture. So the physical layer is based on the WCDMA concept. Now, the physical layer of 3G networks is different from the previous technologies. Now, if we talk about our earlier technologies, that is the previously existing radio paths, which has been implemented by the various networks to achieve the air interface between the user and the serving base stations. So moving towards the radio path basics, the first access technology is FDMA, corresponding to frequency division multiple access. Now this access technology is based on the concept of the division of frequency. That means this is the resource which is divided among the number of users in a particular network. That is the network which is employing FDMA as an access technology. So that means each of the user in the system will have different frequencies. User 1 will have his own independent frequency, similarly user 2 and then user 3. So that means the number of users can have their own independent frequency. This frequency is allocated to this user. That means this is a dedicated resource. This frequency cannot be used by another user until and unless this frequency is freed by this user. So that means in the frequency division multiple access, one frequency can carry only one phone circuit at a time. So if the connection is idle, So that means that frequency resources wastage. So that means this technology does not include more number of users because we know that frequency is a limited resource. So it cannot accommodate more number of users. It cannot support a large number of traffic. Moreover, it doesn't support simultaneous users for a particular channel. So that means we need some more improved and efficient technique which can enhance the performance of the network, which can increase the accommodation for the number of users. So after FDMA, the next roadmap for increasing the number of users to support more number of users is the concept of TDMA. TDMA refers to time division multiple axis. Time. Here it was frequency, so that means the resource which was allocated to the user was frequency here, but in the case of TDMA, the resource which is being allocated to the user is time. So that means time slots. Instead of allocating different frequencies to different users, what we are doing in time division multiple axis, we are allocating different time slots. This is time slot 1, time slot 2, time slot 4, and for example time slot 6. So each user will have its own time slot to carry its transmission. For the reception and transmission of data, we have different time slots. So that means the resource, the frequency can be utilized here more efficiently as compared to this technology. If we have one channel here in TDMA, so this is not allocated to a user dedicatedly. What will happen? This will be divided into different number of time slots. So this time division multiple access technology is used in our GSM systems. So that means if we talk about our GSM systems, each channel is divided into 8 time slot. So that means this channel will be supporting 8 different transmissions. So it can support more number of users. So this technique is an efficient method for carrying the network conversations or our transmissions. Now these were the previously used techniques. This was for our first generation and this was for our second generation of systems. Now our WCDMA concept, our WCDMA, the radio access technology, is based on a third kind of access technology which is referred as CDMA. CDMA implies code division multiple access. Now no restraint of time and frequency. Instead, what we are using here is code. Now, before discussing how these codes are implemented here, we will discuss that on which methodology the CDMA technique is based. CDMA is basically a spreading technique. That is, the CDMA is DSS, direct sequence spread spectrum. Now, first of all, spreading. That means we have to spread our information signal. Spreading the information signal. If this is my information signal, now my information signal is a narrow bandwidth signal. So, in order to increase the bandwidth of this information signal, I will have to multiply this with an spreading sequence. Now, this spreading sequence is basically a higher bandwidth signal. Now, when I'm multiplying my information signal with the spreading sequence, I will be getting in the resultant as a spreaded signal. So, like this is if my information signal, I'm multiplying this here with a wideband signal. So, ultimately, I will have a signal which is spreaded in nature. So that means my information bits, because my signal will have some information bits that will be multiplied with some spreading sequence which will have the rate greater than the information signal. Only then we will have the spreaded signal which will have the higher bandwidth as compared to the original information signal. So this is the concept of CDMA. It is based on the spreading of the information signal. And how we are doing the spreading? We are spreading our signal with the help of some spreading sequence. Now, these spreading sequences are called codes. Code sequences, and also referred as PN codes. Pseudo random codes. Now, these codes have a property that these are orthogonal in nature. That means they have zero cross correlation to each other. They won't interfere with each other. So ultimately what we have in our CDMA system is all the users in a CDMA system will share same frequency. They can transmit at same time. That means simultaneously the users can carry out the transmission. So how they are distinguished? They are distinguished on the basis of these codes. That means every user in this system will be allocated a different set of codes. If this is user 1, you will have code 1. If user 2 will having the code 2. Now both of these users can transmit the data over same frequency and at the same time, but they will be distinguished on the basis of the different codes. So that means at the sending side, which is our transmitting side, these codes are used. The data is transmitted over the same frequency. Then at the receiver side, what will happen? The receiver will also have the same code. So if the receiver has the same code C1, so it will decode the information from this, and you will decode the information if you will be having the code 2. But if here some different code is utilized to decode the information, so it will not decode the information but it will reject it as a noise. So this is the benefit of our CDMA systems, that the information is secured. If the transmitter and the receiver have the same codes, they can get the information, otherwise it is rejected as a noise signal. So that means these are secured systems, and CDMA systems greatly enhances the capacity of our spectrum. That means it can accommodate a large number of users. Our CDMA system can be related, for example, like this is my transmitting side, this is the code for user 1, this is the code for user 2. Here I will mention them separately. Now, these are the different transmissions of different users. These are the different codes. But when I'm transmitting them through a transmitting channel, they will be transmitted simultaneously, because then we will have the spreaded signal. So here they are like this in the path. But what will be happening at the receiving side? Each of the receiving junction will decode their code only. Like 1 towards itself, 2 to its user, 3 on its path, and simultaneously 4 here. So the frequency is shared by all users simultaneously, but they are differentiated on the basis of these codes, on the spreading sequences. These spreading sequences are also sometimes mentioned as the chipping sequences. So the basic principle of CDMA works like this. We have a digitized information signal from here, like this. Now here it will be multiplied with the EN code. We will have a spreaded signal. Now the spreaded signal here is RF modulated to be transmitted on the path. So that is transmitted. This is the function which is carried out at the transmission side, transmitting unit. Digitized signal multiplied with EN code, then RF modulated and transmitted. Now what will happen at the receiving junction? At the receiving side, we will have our spreaded signal. Now this spreaded signal will be demodulated. Now here we'll have the demodulated signal. So in order to decode the information, the same PN code will be used here. This code was used, for example, this ABC01 code was used to spread the data, to encode the data. So what will happen at receiving side? The same code will be used here, and only then we can receive the correct information signal. If I will use another code like ABT01, so it will reject this as noise. So this is the benefit of our CDMA systems, that it makes system highly secured. So our WCDMA also works in this manner, but we are saying that it is a wideband code division multiple access methodology. Because in our CDMA systems, the channel bandwidth is 1.25 megahertz, and here it is increased to 5 megahertz. That's why CDMA can provide speeds only up to 144 Kbps, and our WCDMA systems, that is our UMTS systems, are able to provide speed up to Mbps. So this is the working operation of WCDMA, that they works with the help of code. This is basically a coding technology. Now we will discuss some of the WCDMA parameters. First one of them is the bandwidth, which we know as 5 megahertz. Second one, the operating modes. The operating modes supported here are either TDD or FDD. It uses a direct spread method for its RF downlink structure. Other parameters of WCDMA systems are like the chip rate. As I mentioned, that the coding sequence is also called as chip. Now, as we talk about our data, when data is being transmitted, so we say that this is the data rate. So we have the chip rate, that at which rate these chipping sequences are generated. So this has been greatly enhanced in the case of WCDMA systems also, which is 3.84 MCPS. Next parameter is the frame length. Frame length is here 10 milliseconds, and the number of time slots has 15 time slots per frame. Like in our GSM system, there were only 8 time slots, but here we have 15 time slots for the duration of 10 milliseconds of a frame. Next important parameter of WCDMA is the modulation techniques. Now, WCDMA systems uses BPSK, binary phase shift keying, for uplink, and QPSK, quadrature phase shift keying, for the downlink operation. It is utilizing two different modulation techniques. A different one for uplink, which is BPSK, and a different one for downlink, which is QPSK. Next parameter for WCDMA is the channel coding. It uses two different channel coding techniques. Convolution coding techniques and turbo coding techniques. We will be discussing about the channel coding techniques and the modulation techniques in our further sessions. The handovers which are implemented by WCDMA is softer handovers and interfrequency handovers. It implies different power control techniques also, fast and open power control techniques. Now, the last and the most important WCDMA parameters is the spreading codes. It uses two different kind of spreading codes. First one are the channelization codes, and another one are the scrambling codes. These are also referred as OVSF, orthogonal variable spreading factor. These are mainly used for the purpose of spreading. These are the scrambling codes which are generated as from gold sequences. These channelization codes depends upon the spreading factor, and these scrambling codes are fixed to the number of 512. We will be studying the spreading operation of WCDMA in our further sessions. So today we have discussed about the WCDMA concept. This is the concept which is implemented in the air interface of our 3G networks. So this is the method which is responsible for deploying the physical layer of our 3G systems. We studied the different radio paths starting from FDMA, TDMA, and the one CDMA which is used in our 3G systems. Here we are referring it as a WCDMA, as it's a wideband CDMA technique. We studied the different parameters of WCDMA systems which makes the processing of air interface work. So this is all for today's session. Thank you.